Hey everyone, today we are looking at this LED light bar used for entertainment purposes, and it is a Chauvet Colorstrip Value Innovation Performance, right? And the model number is I cannot immediately see a model number. They just call it the Colorstrip. So I've got 3 of these. Could make an interesting series. I don't know if they're all the same fault or what, but we will start with this one. I guess we'll plug it in, see if it does anything at all. Maybe it's just one color that's out. I don't know. They are DMX controllable, but they also have their own buttons, so you can just set it up as you need. And there's also you can chain them. There's a master slave output down the end there, and there's another controller, external controller socket that may be proprietary. I don't know. DMX is a universal language, I believe. So it's got a standard IEC connector there. Let's plug it in. Where is the power button first? I don't think there is one. Alright. No little crackle from the plug as I insert it. That doesn't mean anything, but sometimes a switching supply will do that. And if we push, let's try mode. Nothing. Hold it down maybe. Nothing. Okay, so I'm assuming it will come. Ha! Okay. I assume something. I assume it will come on automatically. Maybe it takes a minute to do a power up sequence. I don't know. We've still got nothing on the display here. So if I push mode, no, nothing there. What does it look like on the front? Okay, so it has a pattern to it. We've got a bunch of red squares with blank in between, and then green and then blue. So I don't know if that's some kind of test mode, setup mode, I don't know. What if we no, what if we hold down mode again? Oh, we get something on the screen. Okay, it's very unresponsive. If we hold down enter. No. I thought it would be more responsive than that, so it's not very happy whatever's going on. I guess we'll pull it apart and start with anything physically damaged, and then check power rails. Make sure it's got what it needs to run. I think the brain of it's a bit funny. We'll take the feet off the end. Might make it easier to work on, I don't know. Will it? Or will it? Maybe, maybe not. Okay. We'll just spin them out the way for now. Ah, that's tight. Flag that. Let's just undo some screws and see what happens. We've got one at each end and some down the sides. And then I assume that the back will fall out. There's some halfway down as well. And on the other side, along closer to the light bar itself. So I don't know what they are hanging on to, but I guess we'll find out. Let's try a Phillips bit. It'll work better than a Torx bit. They're tight. Ooh. Throw it away. Now there's some here as well, but I'm inclined to think they're holding on to the circuitry behind there. So we'll go for the side screws. They're tight as well. Almost like cross-threaded tight. I wonder if this has been opened before. Sometimes these little star washers will stick onto the body of it or whatever device you've got. They'll stay behind. Make sure you pick them off, otherwise they'll probably fall off and then you'll lose them. Still feels pretty tight. Well, no, there it goes. Give it some encouragement. Feels tight down there. Right. Oh, okay. Can we unplug anything? What would be the best way to remove that? So there's a control board. There's our main control board. Then there's a power driver for the LED panel, and there's just a standard looking. It's a separately boxed power supply, almost like a almost like a modified laptop charger. That's one way to keep everything isolated, I suppose. I'm thinking because things light up, there's probably no problem over here, and because these numbers don't change on the screen with the button pushes, we'll look at this board first. I probably should have got the user manual and figured out how to use the buttons before writing them off as dead. And yes, pushing the mode button should have given us various different digits, letters, whatnot, and we should have been able to scroll through all sorts of numbers and sequences to create different effects and colors. So it was definitely not responding to the buttons, so we're on the right track. I think the easiest way to start, because of the short lead length, I'll just undo this from the back panel and we can get a bit more reach on it. There doesn't appear to be any liquid damage, so that's not going to be our issue. There could be dry joints. I see a little bit of solder across a couple of tracks there, although there is solder mask, but the very edges can sometimes be enough to contact. So whether that's an issue, I don't know, but it is on the 7 segment displays there, so that would only affect that, not the running of it. So we'll scrape that off. A little controller there, not much to it really. Maybe that's board down there is more than just a LED driver. Looks like the brains of it are on there, and this is probably just doing the button and display and sending those signals back to the board inside, which means we need to disassemble it some more. There's our power supply wires. They go. Oh, all the buttons are falling out, so that's all right. Our main power wires go into these little crimped joins, which then split off to this board and the main board. Having trouble following where these wires go, so I'm just going to cut that zip tie. So there is two wires coming out of positive and negative, but where do they go? They both go off to our main board. One is going over to the socket at the end, which is our master slave. Okay, and then one off to the main board here. This is not directly fed, it comes off the main board. How's that for quality workmanship? We got solder blobbed all over the heat shrink, suggesting they use the solder iron to shrink that with. I've done that in the past. But in a commercial device you don't want that, because that could easily come off and roll around inside and short out things you don't like. A couple more screws later and we can pull out the control board. Surface mount, nothing on the bottom side, one large MOSFET there, and then the wires that go off to the front panel, which the front panel appears to be okay, unless it does some sort of self-test and is deciding that maybe the LED current is bad because there's some bad LEDs, I don't know. Again, looking for any obvious signs like liquid damage. It's a very clean looking board, so we will have a look under the microscope for potential dry joints. A little bit of leftover flux from the factory. Doesn't appear to have any previous work or rework done to it. That could be a bit dodgy on the end of R3 there. There's a big hole in the solder joint. Maybe that's... It looks like it is connecting though, but it's not ideal. And the 7-segment displays pins, they all seem to be okay. Yeah, if anything we need to solder up that end of that resistor, but again I'm pretty sure it's still connecting through the edges, and that's only going to the buttons, and we're getting no response from anything, so it's not like we need to worry about that until the rest of it works. Now we don't know if perhaps this IC has failed and it's not... oh, look at that, there's another one that's really quite bad. Look at that, nice big hole in the end of the joint. Again, it does appear to be connecting, but we will resolder that one. And that IC appears to be soldered on alright. But yeah, if that's faulty, let's just have a look at that. What's that IC doing? Okay, so that IC, I think, is actually only doing the display. The other traces that appear to go to the switch connections aren't going back to that IC. So it is all managed on that other PCB, and this is just an input and display board. Alright, let's we shouldn't need to add any more solder. We just need just a little blob of flux, and we can use what's there and what's left on our iron. %, sure that that's not actually going to change anything. We could just plug it in temporarily and see, but again, as I say, that's just one is on the display chip and the other one's on the one of the buttons, which just meant one of the buttons wouldn't work, but not our mode button. So again, I don't think that was our issue at all. Pop that aside and we can have a bit of a look at the main board. I may have to unplug everything, I'm just trying to avoid that, but it's only a couple of plugs, I'm just lazy. So what have we got going on here for bad joints? Probably all of them. There's a couple of okay, 24C16N could be an EEPROM, and there's another IC there, a copy of that IC there, going to our DMX. Okay, so U6 and U5 there could be DMX, well, not DMX controllers perhaps, maybe just like interfaces to translate the data for the micro. Shift it to something else. The crystal appears to be attached. There's a U7 down there. I'm not sure what that's doing. That appears to be attached. These little resistor packs, first time I've seen a dry joint on one of those, maybe a slightly smaller version too, was in an instrument cluster. I'd never expected that. They always seem to be other devices. What's that down there? A bit fluffy looking. Could just be flux. Doesn't look like corrosion though. There's a little bit of green, but that's the glue I think they've used on the connectors. There's a little bit of, let's just see if that's still liquid or not. There's a little bit of something there. Oh, there's something there. No, there. It's solid. It's leftover glue, I think, that from the connectors. They actually glued the connectors on. Obviously with sort of DJ equipment and whatnot, it can be transported a lot, so they've got to make it somewhat resilient to the odd knock. Yeah, it wiped off easy enough. That'll be nothing serious. The connectors at the top, we've got this one going over to the input board, input output board. That one there is going to its own interface, its own little external controller. And then there's our micro, of course, with a sticker on top for their own naming. More resistors, More of that funky stuff. I'm starting to think that could be, perhaps it was some kind of liquid that got in. Almost looks like it's crystallized on the board. Yeah, I don't think that's flux. I think it's something that's got in and then evaporated. And that solder looks a bit crap on those resistors. We will clean that off and resolder those resistors. Another lovely job of leaving solder blobs everywhere on the connector there. I'll get down in here without melting the connectors and the wires. Spread them out the way. Can do. See, it still looks a little bit oxidized on the top edge there. Okay, here's the 245 SK, which stands for small knife as far as I can tell. Slightly shorter, a couple of mils shorter than the big knife, but you know, I need to get me a chisel tip because this is silly. And a chisel tip was not included in the package, unfortunately. There's a couple of different tips that I want to get. Not waste any more time and I'll get them. But for now, we will make do. Alright, bad solder joints taken care of. At least those ones. This funny flaky stuff that may or may not be flux is removed. Tracks look okay, no corrosion on the tracks. Over here is the power side of things. So these connectors here and top and bottom here and here are our LED output connectors, and they drive the LED rows directly. So we've got that large MOSFET there and those large resistors, which would be very suspect for dry joints usually. Storage capacitor there, 470 mic, 16 volts. I thought they'd run a higher voltage actually on those. I guess we need to plug it in and do some measurements, and I guess yeah, see if it has any stable voltages on it, or if our power supply is maybe injecting a whole lot of ripple that's upsetting the operation of things, because micros do not like dirty DC. Can I plug this in safely? Yes, it looks like I can. It's not going to short out on the chassis. So let's do that. The LEDs are unplugged. I have no idea what effect that'll have, if anything. Unplug it from that end while I hang on to the live end just to support the plug going in. You don't want to accidentally touch the back of the socket with its half-assed heat shrink job. And we'll plug that in. Ah, right off the bat, our display lit up. Hey! Right off the bat, hope you can see that, we have A001. Well, we didn't get that before. And we can change mode. And up and down is changing values. Oh, was it that simple? Was it just a little dry joint somewhere? I don't know. Let's plug the LEDs back in and see if it has any other effect on that. Because if we do have a bad supply rail, trying to light up LEDs as well could bring down the supply rail and get it locked up in some state. And they weren't that bright, I thought. I mean, they were bright, but I don't know. I don't know how bright this thing's supposed to be. But certainly, I guess it would somewhat light up an area that it's pointed at. Let's do a before and after voltage check on our supply rail. So I can't measure at the crimps, but I'll go straight to the input there and see what we've got. Oh, I think I saw a blue light flash, or am I imagining things? 11.6 volts. Surely that should be 12. I can't imagine why it wouldn't be 12. If I touch, it's weird, if I touch Yeah, I'm getting a blinking. Okay, there's a blue LED flashing to the audio pickup on this. Yeah, every time I touch the board it could pick it up. Okay, let's plug the lights in. We'll just remove the power first. But yeah, I would have thought it might be on the slightly higher side of 12, not the slightly lower side. Alright, let's see if we get something on the display this time. Oh, we do. Again, it's 88888. It looks like it's in default something wrong mode. So, let's pop that out the way. Double checking our power supply. 6.6 volts. Okay, so our power supply is toast and is not getting enough, and hence they're not very bright as well. Alright, let's rip the supply out, and I bet it'll be the output capacitors guaranteed, but let's have a look. I mean, when a power supply, switching supply like that fails, it tends to be either catastrophic and nothing, or low output just because of bad caps. I guess we'll find that all of them have failed power supplies. How are we going to get that out of there? I need to find out how that's held in. I think it's just double-sided tape. No, there's actually a bracket screwed through there. Oh, that's alright then. I'm just going to screw the in-out panel back on, because we know that's okay, and just stop it hanging out in the way of everything, and then we can work on the other end. A couple of long screws holding the power supply in. Okay, so the bracket goes around the box and is not captive. The bracket just fell off, but that doesn't matter. Now I've got to get the tape. Okay, it's double-sided taped on as well, all the way down. Some tape over the old sticker. Yeah, look at that. 12 volts, 3 amp. And it is absolutely an off-the-shelf unit where they've ripped out the IEC socket, soldered the wires in directly, and yeah, come straight out the end with their own. So should be easy to open then, because they would have only super glued it back together. See if we can give it a crack. Not a hammer. Well, they glued it pretty well. Let me find a bigger, not a hammer. Here's a bigger, not a hammer. You got to be careful doing that you don't push through and stab something important. Now, of course, mains operated device. There will be a capacitor in here that you do not want to touch. It's probably discharged by now. There's our big capacitor there, and that solders on to, appears to be there and there. I can take a quick measurement of that. Okay, we're at 7 volts. Nice and safe. Had you been keenly observant during that little rotation of the board, you would have noticed this is bulged. So we will replace, I think we'll replace both of these just for longevity, and everything should be happy again. Our heatsink's waggling around there, just siliconed on. Usually they've got a pin through to the PCB that holds it down and stops it doing that. It's not very good, not for something that moves around a lot. But anyway, let's get those caps out. What do we got? 1000 mic, 16 volt. The next problem with this scenario is when you're a hobbyist, you don't have all the values. In all the small sizes. So let's see what I've got that we can put in there. I need to go for a trip and get a couple of caps. Now today my only option appears to be 470 microfarad in a physical package that'll fit in here. So I need to order a bunch. I'm going to see if they have maybe 680s in a smaller one. There's nothing on their website. Silicon is putting up a fight. Let's test that one just to see how bad it is, even though it's not the bulged one. This might work. The leads are a bit short. Battery's getting a bit flat, I think. Yeah, 1000 mic at 0.1 ohms, so that one's probably pretty good. If I can only put a 470 in, I think I'd leave this one in as well, just to support it. That's good still. I just went and bought, well, let's have a look. I could maybe squeeze that in. That's 10mm diameter, not 8mm diameter, but I could only get 470 mic in an 8mm diameter. I'm just gonna cut away some of that silicon. Just curious to see maybe if I could cram a couple of the big ones in which case I'll have to go back because I only bought a few of each. That's if the other supply is also bad. The other 3 units I've got, which is every likelihood that they're all just this. Yeah. It's hard up against the inductor. Okay, that's not going to happen. That's a shame. We'll get that old one back in there. There we go. Let's see, we probably can't, but whether we can get the big one in beside it. I'll probably get in the way of that inductor again. Oh, look at that. That is not gonna be taller than the rest of it. Yeah, that's gonna work. Which is good, because then we get our full capacity back. Test it before we glue it together. And for maximum effect, I've turned off the bench light, so make sure that's main board sitting okay, not touching any metal. Let's plug it in. Oh, it's much brighter. And what's it doing? It's blinking. Oh, okay. Let me just turn that off for a sec. I appear to have got the mode button stuck. This is quite a flimsy setup. The mode button appears to have fallen out of place. I'll have to fully relieve that lower screw. Okay, I'll hold it there. This will be alright once we clamp it back in the frame, of course. It'll straighten up. Good, it's stable. That button being held down didn't help. So, enter. Cool. Disco. Blue. Something. Awesome. That's fixed. Reassembling this. Get the board back down in there. Am I going to have enough slack to glue the power supply if I do that? Yes, I will. Alright, let's get that bolted back in. Hopefully the quality of the videos will improve shortly, because I have just ordered a what I believe to be a decent LED floodlight, so that I can try and get more clarity around what the camera's looking at, upping the exposure to try and show things, and then I can have it pointed at, you know, from this way instead of relying on the lights above and behind, because it's usually all this front stuff that you guys, well, I don't say can't see, but that doesn't show up as clear. What would we do without hot glue? Just easier to push another stick through than pull the trigger. And tucking that all back in. What am I missing? I've got a bunch of self-tapper screws, and I've got one machine screw left over. These are all self-tappers around the side. What's going on? I've decided that the short threaded screw goes beside the mains connector, and the other ones, which are slightly pointy, will go in beside the power supply and kind of just graze the corner of it as it goes up. You can see where one's been digging in already, so that's the way they want it, that's the way they get it. And there we have it. That's all the LEDs lit up, functioning as it should. And stay tuned for the other two. We'll see if they were the same problem or something a bit different. Thanks for watching.